All right, y'all. So today we are starting to look at unit conversions. Unit conversions are probably something that you've been doing for a really long time. Sometimes it's called dimensional analysis, train tracks. It started when you were younger, just learning simple things like 60 seconds are in 1 minute, or 1 minute has 60 seconds. Then, as you went through science, you probably started to learn some different conversion factors to use. You did some probably in middle school, some in lower school. We are going to continue to use unit conversions slash dimensional analysis this whole year. So whether it be actually converting between something like a centimeter and a meter, which is where we will start, the process of train tracks is something that we are going to keep using all year. Okay. And so while it may seem sometimes silly, some of the problems I'm asking you to do, the key part about this is the actual process of dimensional analysis. So true in the real world. I'm not really going to be asking you in chemistry about hamburgers and salaries and things like that. But I do need you to understand how to pull information from a question and put it into a complex calculation. So let's go ahead and get started. Okay, so these are the metric prefixes that you are going to use for this class. Now, please know there's way more metric prefixes out there. You've probably heard of giga and nano and things like that. These are the 6 that are going to come up in a high school chemistry class, so these are the 6 that we need to know. If we're ever going to play around with any of the other prefixes, I will tell you what they mean. So kilo is 1,000, hecto is 100, deca is 10, deci is 1/10, centi is 1/100th, and milli is 1,000. Okay, then in the middle we have what we call our base. So you could have a kilometer, a kilogram, a kiloliter, whatever. Okay, and it's always a good idea to keep in your head, like, what's bigger, a kilogram or a centigram, a hectogram or a milligram, a deciliter or a kiloliter, right? Always a good idea. And so remembering them in this order will be super helpful. And so a little silly way to help you remember that is King Henry died drinking chocolate milk. Okay, happy for you to come up with your own acronym if you would like, but that's one that can be helpful.
1,000 kilo, 100 hecto, 10 is decameters, 1/10 deci, 100 centi, 1,000 is millimeters, 1 decameter is 10 meters, 1 hectometer is 100 meters, 1 kilometer is 1,000 meters, and here is how we remember 1,000 kilo, 100 hecto, 10 is decameters, 1/10 deci, 100 centi, 1,000 is millimeters, 1 decimeter is 1/10 of a meter, 100th is a centimeter, 1 millimeter is 1,000th of a meter, and here is how we remember 1,000 kilo, 100 hecto, 10 is decameters, 1/10 deci, 100 centi, 1,000 is millimeters, 1,000 kilo, 100 hecto, 10 is decameters, 1/10 deci, 100 centi, 1,000 is millimeters.
Okay, so hopefully you enjoyed that song. It's probably going to be stuck in your head, but that's kind of the goal. And so you can go back and watch it whenever you want to get it stuck in your head. Okay, so conversion factors. I referenced that word earlier. A conversion factor is something that is used to go from one unit to another. The conversion factors specifically are equivalences. So 60 seconds in 1 minute, 100 centimeters in a meter, anything like that, anything that is an equivalence. Your height is 5'6", right? My height equals 5'6", 5'6" equals my height. 60 miles per hour. In 1 hour, you're going 60 miles. Any of these things are conversion factors, and we use them to go between one unit and another. So for example, that's 60 miles per hour. I can use that information to figure out how far I might go in 2 hours, right? And so I'm using that equivalence of the 60 miles in 1 hour to get me to figure out how far I'm going in 2 hours. So English units, these are things that we like to use in our country, miles, feet, yard, inches, things like that. But most of the science world uses the metric system. So when we are talking about our metric units, I think it is more helpful. So the fact that deci is a tenth or centi is a hundredth is great. But I think it's easier to keep everything with whole numbers, no decimals, no fractions in my head. And so what you will see right here is that it says 1 kilo and then a star, because that star represents a meter, a liter, a gram, whatever. Okay. So 1 kilo, whatever, is 1,000 whatevers. Then down here, when we get to our small friends, our deci, centis, millis, I've changed it to 1 whatever is 10 decis. Instead of saying 1/10 of a gram is 1 decigram, I think it's easier to say 10 decigrams makes up 1 gram. So remember, these stars are always representing our base. We got to keep that base term straight in our head. Now, you notice this thing right here that's purple with a big star. This, friend, is what we call our magic converter. And the reason that this is so important is it's the only way that we can convert from English units like miles, feet, and yards into metric units like kilometers, decimeters, and centimeters. So again, this is our magic friend. You do need to memorize this conversion factor. And again, magic, magic, magic. All right, so let's take a look at going between these things. So when we set up these problems, we are going to use something that I like to call train tracks. You can call it dimensional analysis. You can call it unit conversions, whatever. So notice right here, I have no numbers involved. I just have a bunch of words, okay? And so what you'll see is that the units you are in, you want them to go diagonally to the units that you are in. Because what happens when we set up these problems is that we are trying to get out of one unit and get into a new unit. And so by canceling on that diagonal, we are essentially dividing by them, okay? This friend right here, that is going to be your conversion factor. Okay, so your 60 miles per hour, your 100 centimeters in 1 meter, your 1,000 meters in 1 kilometer, your whatever. Okay, that conversion factor, they are always directly like on top of each other like that. Things that are facts, things that are equivalences, go like that. 1 cake takes 2 eggs, like literally anything that is an equivalence, that's like a recipe, is going to go on top. And then again, diagonally, that's where you are seeing those units cancel, okay? After you get your units plugged in, then you actually are going to plug in your numbers. I think it is super helpful. Some of these train tracks can get really long to go like think through your units first and then go back and plug those numbers in. And so this is a super important question right here. Ask yourself which unit is larger. So the reason that this is a really good question to ask yourself is because that is the unit that's going to get the 1 in front of it. You all know that there are 60 seconds in 1 minute. But something happens when we're in that like test environment and we're writing things down, and all of a sudden we write that there are 60 minutes in 1 second. Even though before you took this class, you already knew that that wasn't true. Okay, so by taking the time to ask yourself for each conversion factor, what is bigger, then that will help you keep your brain straight. I promise. It may seem silly. Like, you guys know that there's 100 pennies in a dollar, not $100 in a penny. Something happens. We go to the paper and we're like, boom, $100 equals 1 penny. Okay, so take the time and ask yourself what's bigger. Then you're going to put this stuff into your calculator. So again, you're going to end up with these kind of long looking things like that, okay, where you have all these different conversion factors put together. Anything on the top, you multiply by. So times, times, times. Anything on the bottom, you divide by, okay? And so on the bottom, divided by, divided by, divided by. So when you plug something like this into your calculator, you'll take like whatever is right here, times this, times this, times this, divided by this, divided by this, divided by this, okay? Now, multiplying and dividing by 1, that, friend, you don't have to do. We'll see a lot of 1s, but that is a good practice. So times, 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 everything on the top, divided by, divided by, divided by, anything on the bottom. So go ahead and take a pause and read through these steps. All right, so here we go. Here's looking at a problem. It says 15 centimeters to millimeters. So the first thing you really want to make sure that you do, okay, is think about what is your base when you are converting in that metric system. So always ask yourself, what is the base when we're looking at the metric system? So for this question, what's the base? Okay, hopefully you said meter, or you're like, oh, I don't remember what bases are. Remember that base is your meter, gram, liter, whatever. And so our base for this question is the meter. So that tells me that I'm going to go from centimeters to meters and then meters to millimeters. That's kind of how that thought process needs to go for you. All right, so always go to that base first. Then, as our direction said, start with what you are given. So that's our 15.2 centimeters. That's what we were given in the question. All right. Then we think about our conversion factor. So I am in centimeters. My base is meters. So I need to go from centimeters to meters. So I need to think about that as a conversion factor. So remember, we're canceling on that diagonal. Fancy. Diagonal. 5 centimeters here. That means diagonally, I have to have that centimeter. Okay, and then again, I'm going to my base, which is meters. So step number 1, figure out your base. Step number 2, start with what you're given, put it out there, and then always, key thing, cancel on that diagonal. Cancel on the diagonal. Cancel on the diagonal. Make sure your units cancel on the diagonal. Did you get that? Cancel on the diagonal. What do you need to do? Okay, great. Hopefully that's in all of our heads, because that's going to be true about train tracks forever. Okay, so now I've got them canceled in the diagonal. Then that next part of that next question, so 1, cancel on the diagonal. 2, the next question we had was what unit is bigger, right? So I've got a meter and a centimeter. Take the time, take a breath. What's bigger, a meter or a centimeter? A meter is bigger, so that is what gets the 1. And then I think, okay, centi tells me 100. So I've got 100 centimeters. That's how that thought process needs to go for you. Cancel the unit on the diagonal, go to your base, and then which one's bigger? Great, so I got to my base, but that's not the unit the question was asking for. So then we keep going. So I have a meter here, which means I need to put a meter here. The question's asking for millimeters, so that goes on top. All right, now I'm thinking about, okay, meter and millimeter, which one's bigger? A meter is bigger, so it gets the 1, and then the 1,000 goes on top. Okay, so asking yourself what's bigger, making sure those units cancel on diagonal, keeping straight what is your base. Those are going to help you get through these problems. Then for your calculator, remember, everything on top you are multiplying by. The eraser's not working. Sure. Everything on top you are going to multiply by. Everything on the bottom you are going to divide by. So give yourself a big multiplication symbol up there, division symbol down here. So if I was plugging this into my calculator, I would type 15.2 times 1,000 divided by 100. Okay, so that is the process that you want to use. So now go ahead and give this one a go. There is some question about scientific notation. If you are not familiar with this, you can simply just plug this into your calculator and start there. Like think of it as math, or if you're a friend who's comfortable with scientific notation, remember you just move that decimal. So up to you, but go ahead and plug that one in and give me an answer. All right, let's do another one. Okay, and again, keep in mind base, right? What's your base unit when you are doing these things? All right, so you have a given, get to your base, and then get out of it. You got it. All right, so hopefully you got through that. Now let's take a look at this friend here. So this one gets a little special attention because it has our super confusing, super special going between metric and English, right? So it's not that perfect like centimeter to kilometer, yay, all metric. No, now we are going in between units from 2 different scales. And so when that is the case, you need to keep in mind that you have to use this magic converter to get through it, okay? So 2.54 centimeters equals 1 inch. You always have to use that when we're going between metric and English. So if you're starting with metric, take whatever you have and get it to centimeters. If you're starting in English, take whatever you have and get it to English, okay? Again, this is our magic converter to get through it. So just like before, you start with what you're given, 27.2 centimeters. Centimeters on the bottom, right? Always having those friends cancel on the diagonal. And then I can put inches on top because I can directly relate inches and centimeters. There is a conversion factor for that. 2.54 centimeters is 1 inch, and you plug it in. All right, so go ahead and solve for this one and give me an answer. And give me an answer here.